Okay, question C. Now this guy who made this paper really likes these sort of statement questions. This literally looks like part A, right? I mean question A, right? Same thing, like which of the statements are true, and that sort of thing. Okay, either way. So 1C. So which of the following are true for all real values of x? All arguments are in radians. Okay, well, basically we could just have a look at it and then see. Okay, well, obviously, this one is definitely trash, right? Because this is pi over 2 is an odd. Okay, perhaps it might be tricky if I explain it this way, but sine of pi over 2 plus something, this has to become some sort of cosine x, right? It has to become some sort of cosine x. If you guys get what I mean, like if you add like multiples of well, if you add something which is not a multiple of pi, let's say, then it goes in antiphase. Like if you add something which is k pi over 2, where k is odd, then it goes in antiphase. More of a physics word, but it goes antiphase, and so this sine has become cosine, but hey, cosine is pi over 2 again, so it will go antiphase again. So this is a sine thing in general. So hopefully that explanation was good enough. It's quite confusing about these phases. That's how I think about it, though. So this left hand side is cosine, right hand side is sine, so they won't be equal, right? So one is no good, and so A and B are both no good. Okay. All right, cool. Let's look at 2. So 2 is when you see cosine squared and you see sine and you see like a constant, well then obviously you probably want to make it into a quadratic, right? So cosine squared is 1 minus sine squared, as we all know. Okay, so this becomes right. 2 plus 2 sine x minus 1 plus sine squared x. Okay, and this equals to what? This equals to, well, sine squared x plus 2 sine x plus 1. So here, well, this is a perfect square, right? This is just sine x plus 1 all squared. And that is indeed always greater than 0. Okay, and so yes, that is greater or equal to 0. Sorry, so greater or equal to 0. That's indeed true, right? That's indeed true. So 2 is good. All right, so we could get rid of D. All right, so next one. Let's go 3, shall we? So, okay, let me get rid of this so we make space. And 3 sine of x plus 3 pi on 2 equals to cosine of pi minus x. Okay, so this again, 3 pi over 2, 3 is odd, right? So it makes it antiphase. So sine has become some sort of cosine x. And this is a cosine, well, this is pi, right? So pi makes it in phase. So cosine is still cosine. So 3 is definitely possible. Okay, it's definitely possible. Okay, so we now have to check. So let's look at the right hand side first because it's easier, right? Okay, so cosine pi minus x. Okay, so when you subtract pi from cosine, this becomes what? Like this becomes, okay, minus cosine of minus x, right? Because think about when you move the cosine graph to the left or to the right by pi. The graph literally is reflected in the x-axis, right? So the y values are literally swapped. So basically you put a negative in front, right? And the pi disappears. So now I have minus cosine of minus x, which gives what? Well, this gives, well, cosine is even, right? Even function, so this is minus cosine of x, right? Same thing. Okay, so the right-hand side we know is negative cosine of x. Cool. All right, now let's look at the right-hand side. No, the left-hand side instead. So x plus 3 pi over 2. So we know that this has to be some sort of plus or minus cosine x, okay? So now, for me, I know that this has to be true. Well, technically, this is not quite a good equation to write down, okay? It's not as rigorous, but, that's the thought in, our brains. So what I do is that, okay, just try a random value of x, right? So for example, let's put x is 0. So cosine 0 is 1, right? And sine of, here, if I put x is 0, what is sine of 3 pi on 2? Well, sine of 3 pi on 2 is minus 1, right? It's minus 1. So we know that this is also minus cosine of x, right? Because you need the minus to make this equality hold, all right? So in that case, left-hand side is minus cosine, right-hand side is also minus cosine, so haha, 3 is correct, okay? So, well, if 3 is correct, then we know it's C, right? So last thing, why is 4 wrong? You could quickly think about that. Why is 4 wrong in general? Well, obviously when, x is pi on 4, then this thing explodes, right? So, sine of pi on 4 is root 2 on 2. Like root 2 on 2 times root 2 on 2, what's that? That is 2 on 4, which is greater than a quarter, right? So that breaks rule 4 straight away by one counterexample. Okay, great. So yeah, there we go. Hopefully the phase and antiphase, that logic hits you. I mean, if it doesn't hit you, then I'm sure there are other ways to figure it out. The one thing though is that never try to memorize like, oh no, sine of pi over 2 plus x. What on earth is that? Is that minus cosine x or plus cosine x? Never memorize these sort of identities. Okay, these are the useless trig identities to me. Okay, so what you do is that you think about phase and antiphase, and you think about, okay, should it be plus or minus? As I demonstrated here, you could figure out if it's plus or minus by just subbing in a random convenient value, right? I did x equals 0. That's easy. Right, so that's what I think. People think differently, but my view is that. Okay, so try not to memorize. Oh no, sine x plus 3 pi on 2. What is that? That has to be minus cosine x. Don't memorize it, but actually try to understand where it actually comes from. All right.